Hi everyone, welcome back to Mind Maths with Amla. In this lesson, I'm going to continue solving the practice questions given in the M1 study guide given by University of London. This is chapter 3 called Differentiation, and we're going to begin this lesson with question 3.5. Okay, the question goes as follows. Suppose you have a 19th century painting currently worth $2,000 and that its value will increase steadily at 500 per year. So the amount realized by selling the painting after T years will be this. An economic model shows that the optimal time to sell its value of T for which the function, okay, this is the function, is maximized. Okay, given this, find the optimal time to sell and verify that it is optimal. Okay, so since it's asking for the optimal time to sell, we should take the derivative of P with respect to T, and we should just put it equals to a 0. We'll have to use the product rule because these are two functions of T being multiplied. So let's keep the first function, let me just first write the derivative. Let's keep the first function as it is and multiply it with the derivative of the other one. So the derivative is a minus 0.1 into E minus 0.1 T. Okay, and then we're going to add, put a plus sign here, keep the second function of T as it is and multiply it with the derivative of the first, which is 500. Okay, if I take E minus 0.1 T out as common, I'm going to be left with a minus 0.1 into a 2000 plus a 500 T plus a 500. Okay, so if I open the bracket up, I'll get minus 200 plus, minus, what am I doing? Minus 50 T plus a 500. Okay, so I have, was it a 0.1 or 0. It is a 0.1. Let me just use a calculator. I'm feeling suspicious. 2000 multiplied by a 0.1 is a 200. Okay, so then I have E minus 0.1 T into 300 minus 50 T. Okay, so remember, we need to put the first derivative and put it equals to a 0. Since the x lies everywhere above the x-axis, so this cannot be equals to a 0. Therefore, the other expression will have to be equals to a 0. So this is going to give us the optimal time. The optimal time is now 300 divided by a 50, and which gives us a 6. Okay, so therefore the optimal time is 6. Because we want to make sure that the revenue is being maximized, therefore we need the double derivative at t is equals to 6 to be less than 0. So we'll have to find the expression for the double derivative first. This was the first derivative. As you can see, again, these are two functions of t being multiplied. Therefore, I will have to use the product rule. So I'm going to put the first function of t as it is and multiply it by the derivative of the second. Then I'm going to keep the second function as it is and multiply it by the derivative of the first function of t. Okay. If I take E 0.1 T out as common, I'm going to be left with a minus 50, minus 30 plus 5T. Okay, so this is a minus 0.1 T and this is a minus 80 plus 5t. So we are actually interested in the value when t is equals to a 6. So this is 0.1 t, and we have a minus 80 plus 6 into 5 is a 30. As you can see, we're going to get a negative value because a 30 minus an 80 is a minus 50. So therefore, we are going to get the double derivative is going to be negative. So this is a local maximum. That's all we wanted to prove. We have a local maximum. And actually what we can also do is that if we take the limit of the main function, which was pt is a 2000 plus a 500t multiplied by e minus 0.1 into a t. So if I take the limiting behavior of this function as t approaches infinity, I can see that the value of e is going to approaching minus infinity is actually going to approach a 0. So however, again, we can't actually do anything about this limit because I am basically going to be multiplying an infinity with a 0, and that essentially doesn't make sense. Excuse me. Okay, which means we need to apply the L'Hopital result. However, what I can tell you is that this decays faster, so it basically dominates. The impact of this dominates the impact of this. So the impact of the polynomial is dominated by e power e 0.1t, so it does converge to a 0. Therefore, the local maximum is going to be a global maximum. Okay, moving on to the next question. The monopolist's average cost function is given by this. Her demand is this. If P and Q are price and quantity respectively, find expressions for the total revenue of the and for the profits. Okay, that's easy enough. Total revenue is basically price into quantity. And the price over here is given as 20 minus 2q. We multiply it by q, and therefore the total revenue becomes a 20q minus 2q square. And they want us to find the total, the profit function. For that, we need total cost, which is average cost. Actually average cost into quantity, because average cost is total cost divided by quantity. So that means that total cost is average cost into quantity. So therefore the total cost function is 10q plus 20 plus q square. Okay, the profit function therefore becomes total revenue minus total cost. Total revenue is a 20q minus 2q square minus 10q minus 20 minus q square. So this is basically our, actually we should simplify it. This becomes a 10q minus a 3q square minus a 20. So this is nicer because it's simplified. Now we want to determine the value of q which maximizes total revenue, and also the q that maximizes profit. So what we can do is we want to maximize total revenue, see where that is maximized, and we want to see where profit is maximized. Most probably they won't be the same quantities. So the total revenue function is a 20q minus 2q square. So the derivative with respect to quantity is going to be a 20 minus 4q, and we're going to put it equals to a 0. So the quantity at which total revenue is maximized is a 20 divided by a 4. See, I was making a stupid error again. A 20 divided by 4 is a 5, 4s are 20, yeah. What about the total profit function? The total profit function is a 10q minus 3q square minus 20. The derivative is a 10 minus 6q. So when I put it equals to a 0, I'll get a q star, which is a 10 over a 6. So a 10 over a 6 is basically 2 3s are 6, 2 5s are 10. So the double derivative, as you can see, is negative, so this does give us a maximum profit. And even the double derivative here is a minus 4, so even that gives us a positive, like maximizing, it maximizes the total revenue. The next question is question 3.7. It says the firm's average cost function is given by this. Okay, so if the average cost is given by 300 over a q minus 10 plus q, we know average cost is actually total cost over quantity. So therefore we have the total cost function being equals to average cost multiplied by quantity. So when we multiply it through by quantity, we get fixed costs of 300, and then we get variable cost of 10q plus q square. Okay. The demand function is given by this. Okay, so what will be the total revenue? The total revenue is basically price into quantity. The price given by this, if we make P the subject, we're going to get a 850 minus a Q over a 5, right? So that means I'm going to substitute the value of P over here. The reason why I'm doing this, because I can see everything is in terms of quantity. So I should make price the subject and substitute it in. The answer therefore becomes 850 Q minus Q square over a 5. So it says, suppose the firm is a monopoly, find expressions for the total revenue and for the total profit. Okay, we've already stated what the total revenue would look like. You can also actually just divide it by a 0.5 and make it nicer. Divide by 5. 850 divided by a 5 is a 170q, and 1 divided by 5 is a 0.2q square. So the total profit function is simply total revenue minus total cost. So I have a 170q minus a 0.2q square minus a 300 plus a 10q minus a q square. So we can actually simplify this, and we'll have a 180q minus a 1.2q square minus a 300. So we want to maximize the profit, so I'm going to take the derivative and put it equals to a 0. The derivative is 120 minus a 2.4q, and as you can see, the double derivative is a minus 2.4. It is negative, so therefore we are getting a maximum point. So when I take the first derivative and I put it equals to a 0, I have a 180 minus a 2.4q is equals to a 0, right? So we have a 2.4q is equals to a 180, and therefore q is equals to 180 divided by a 2.4, and this gives us a 75. This was the last sample. No, this wasn't a sample examination question. These are practice questions. So this was the last practice question given in the study guide, and after this there are sample examination questions given in the study guide that I will solve next. This is enough for this video, and I will see you in the next one. Take care.